Hello, am I audible?
Yes, ma'am.
Good
Yes,
afternoon.
continue.
Good afternoon, everyone. I hope you all are doing well. I am Unnati Dabhade, student of third year computer department, and I warmly welcome you all to the day 3 of our 5-day online faculty development program on emerging trends in technology and innovation for digital transformation. Yesterday, on day 2, we learned about a highly impactful and insightful topic that is enterprise system design. The session gave us a deeper understanding of designing scalable architectures, system communication pattern, and building high performance enterprise application. And today, on day 3, we move into one of the most cutting edge and rapidly evolving areas of technology. Our topic for today is Agentic AI. Agentic AI represent the next leap in architecture, artificial intelligence. Systems that can reason, make decisions, take autonomous actions, and collaborate intelligently with humans. Through today's session, we will understand how agentic workflows are built, how AI systems gain autonomy, and how this technology is reshaping industries across the globe. I'm very happy to welcome our speaker for today, Mr. Deepak Patil, sir, Senior Principal at GoDaddy Pune. Thank you, sir, for joining us.
Thank you all. I
I
hope.
also extend a warm welcome to all respected faculty members and participants present for today's session. It is my privilege to introduce our today's esteemed speaker, Mr. Deepak Patil, sir. Sir is a highly accomplished senior principal engineer and technology leader with more than 25 years of experience in building and scaling high-impact enterprise platforms. He has worked with globally renowned organizations such as GoDaddy, ICERTIS, Cognizant, and T-Systems. His expertise include AI architecture, cloud native engineering, large-scale SaaS platform design, system scalability, and observability. At GoDaddy, Sir has drives the architecture and AI roadmap for the next generation customers and commerce system. Previously, at ICERTIS, he led major platforms enhancements including AKS containerization, open telemetry implementation, advanced observability, cost optimization strategies. These initiatives result in significant improvements in platform reliability, performance, and efficiency. Sir is known for simplifying complex system landscape and forecasting strong engineering culture and anticipating emerging technology trends. He frequently works at intersection of AI, cloud, platform engineering, helping organizations innovate and scale with confidence. We are truly honored to have him with us today. Thank you, sir.
Thank you.
Yes. We kindly request you to begin the session, sir. Please, sir.
Okay. I hope you are able to see my screen.
Yes, sir.
Okay. So today's topic is agentic AI. I know yesterday you have worked on or looked at system design. So and then there are few topics today, tomorrow evening you are going to do, and again generative AI. Obviously, there is a correlation between what I've been talking and what you would see within generative AI as part of that discussion, right? But being an AI and LLM, right? I would say this slide represents what when it comes to talking about AI technologies, when it comes to talking about NLU, NLP, ML, AI, RNN, ANNs, and agents, finally, right? Now, everybody has its own definition of what is meant by AI agent. So I don't think what it means, what you think it means, right? So let's, in today's agenda would be, how do we clearly articulate what is an agent, what is an AI agent, how it is differentiated from robotic agents, which many of you would have heard about RPA, and then what it takes for agentic AI. Does AI agent and agentic AI same, right? That is what we would be discussing today, right? So before we begin, obviously, Unnati has given my introduction. Just to reiterate, I look after platform and architecture at GoDaddy. Many of you, if they know GoDaddy, we are the largest domain provider within the world. So if you consider any domain name, 30% of domain names worldwide are managed by GoDaddy and our domain name servers. So that means one third of internet traffic goes through us today. So if we are down, one third of the world's internet will be down, right? As simple as that. And that is where we use AI technologies to a large extent in such a way that systems are available to the extent of five nines. When I say five nine, it is 99.999%, which means yearly I would get a 12 seconds of downtime, right? That is how we design, how we run our systems, right? Uh, in terms of AI usage, we have been playing around a lot, and you would see world has been playing around a lot, and there are views each author, each developer, each engineer, or even each architect would have, right? So whatever I'm talking today are my personal views. Obviously, there are differentiated views across the community, and obviously, I will not be talking on behalf of my employer because there might be certain views that we will be using at our workplace than what I have because of workplace consideration, right? So going forward, what we'll be discussing? We'll be discussing on what does it mean in terms of LLMs, RAGs, and so on and so forth. We'll touch base upon AI agents. We will talk about architectures in terms of how do you build AI agents and what are various protocols associated with it, be it MCP or A2A protocol. The most important topic when you are talking about AI or LLMs, I would say, is context engineering, right? You keep on hearing tokens, and everybody is into rat race of increasing tokens and context windows. So, what does that mean, and how does that impact to your day-to-day operations? So, we will talk about context engineering. One of the important topic when it comes to any workflow or agentic workflow is durable executions, right? How do you ensure that your executions of workflows are durable, which means any activity that I triggered today gets successfully completed, and if it is a long running task, it also gets successfully completed without much of retries. But at the same time, if it does not, then at any point in time at later stage, maybe let's say after 3 months or 6 months, that activity can be restarted from the state that it has been, right? For example, let's take a case that you are doing a quarterly results for a company. Now quarterly results are end of the quarter, means four times in a year that activity would be performed. Now, if I have a workflow that runs only four times in a year and I started at the start of a year, which means it should get completed at the first day of first quarter, end of first quarter, which is 1st of April. So in that case, how do you manage the state for that program for the 90 days, right? And that is where the durable executions come into play. We will talk about that because these are the two key foundations apart from LLM, context engineering, and durable executions that help you to build the AI agents and agentic workflows. Okay. Meanwhile, if you think that any other topic is of interest, which we need to discuss, feel free to type in message, and I would be happy to cover those. Considering the time session that we have, I have actually consolidated some of the topics as well as kept it to bare minimum so that I can have a good amount of discussion on those, right? So now, what is an AI landscape, right? So if you look at AI today, right, in terms of where does it gets used, right? So there are four major ways AI is transforming the enterprise workflow or business workflow, right? If it is from summarization to assistance to building and then enabling the information, right? What does that mean? If we look at any of the systems, let's say today you use banking system and you create a ticket for a bank if something doesn't work, right? And then you have incidents for it. So yeah, it starts from summarizing raw incident data, which means your modern LLMs can process large volume of this operational data, right? You would have your banking system, you would have its own logs, you would have its own alerts, and then you would have incidents that has been raised by customers, by internal IT teams. There might be some code differences between whatever the developer has pushed onto the production versions versus stage versions, and so on and so forth, right? So these LLMs can process this large volume of operational data that comes into play and summarize them into a clear, actionable insight, right? So that is the first part of here, right? You get a summary and context created. Now, where does it help? Obviously, you as an engineer, you don't want to manually look at logs, incident notes, because the LLM would help you to extract the root causes, patterns, anomalies, whatever the next steps are, right? So, which means you are actually moving towards a better stable environments, which reduces MTTR. Anybody can tell what is MTTR? So MTTR is mean time to resolve, right? So there are two fundamental metrics that any organization that runs platform monitors. One is mean time to detect, MTTD, which means whenever any issue occurs within the system, how much time it takes for the system owners, or you would have heard term cloud ops, DevOps, and SRE, reliability engineering team. So how much time it takes for SRE team to identify or detect that issue has happened before a customer is reporting that issue, right? Which means that is my MTTD. Everybody tries to lower down the MTTD because anybody who is running the platform, they should be knowing the issues upfront than customer reporting to them, right? Because if customer is reporting the issue, which means that's a scenario where you don't know what is happening under the hood in your own world, right? So everybody wants to reduce that. And once you detect, how much time it takes to resolve it, right? And that is where your MTTR is, mean time to resolve. Lower the MTTR, better it is, because you are able to push better amount of fixes or good amount of fixes onto your platform, which increases the platform stability, right? Now, using AI or these modern LLMs, obviously, it helps you to churn out the data faster, and it reduces the MTTR, where you are actually focusing on resolution instead of doing the data parsing from the tons of log. The another case is today everybody talks about chatbots and everything. So obviously, human AI augments the human analysis. It does conversations and then act as a first respondent to information. For example, the way any hosting provider today, if you look at our scenario, we host close to 80 million domains, 20 million sites, right? Websites. Now, these 20 million websites would be running, and some website might have been issued, right? It is humanly impossible to monitor all those 20 million website by humans and then figure out what is happening under each website, right? That's where these AI assistants play a role. They crawl, they monitor, and they become the first responder of the information, right? So cognitive load from the human is reduced, and then AI is taking over that as part of AI assistant, right? Data extractions, all of you must be knowing it because you have been doing or studying it day in, day out, where unstructured information, right from PDF, manuals, emails, get extracted and then converted into an entities, relationships, events, and then metadata, right? Now, data silos that used to happen earlier because of this unstructured information is now converting into connected knowledge graph, right? So that you know each of these entities, their correlations, and how they are impacting. If one changes, what should be the impact on other, right? So that is where AI helps. And then the last but not the least, which is more important from the agents, AI agents and agentic AI perspective, is search and contextual retrieval, right? And that's where a terminology which is retrieval augmented generation comes into place, right? So documents are converted into embeddings, they store into a vector database, So when a user asks a question, system retrieves only the most relevant content, right, and feeds it into LLM. So if you look at RDBMS parlance, you used to write queries where you would put on various soundex clauses, so you don't need to do that now, right? So that would ensure that you have up-to-date, accurate, and grounded answers based on your private data of the organization. Public data obviously available through Google indexes or Bing indexes, coupled with your private data, would provide you accurate information, right? And that's where RAG becomes more essential. We'll be talking about RAGs because they are the essential components of the AI subsystem. Now, when I talk about knowledge enhanced LLMs, right? Now, what do you mean by that, right? Now, if you look at it, large language models are powerful, but by default, what they know is what they are trained on, right? Which means you have a set of data set. On that data set, you got trained, and now you are intelligent enough to address any questions on that database, but they don't automatically understand what are the data inside an organization. For example, as a College of Engineering Kopargaon, you would have set up certain internal policies. You would have set up your own assignments which are not available in public domain, or you would have your own set of manuals or faculty data, student data, or any specific lab workflows, right? So these are not known to outside world, which means your LLMs are not trained using that data, right? And this is where there is a gap, right? So LLM takes a prompt from the user, but that alone is not enough for highly accurate result, right? Because the internal data is not available for LLM, and that's where we need to enrich the model with the knowledge that is from internal data, documents, databases, whatever it may be. So when we combine the model with this injected knowledge from the organization, the responses become far more precise, right? They would be contextual as well as reliable. And that is what I mean by knowledge enhanced LLMs, right? So by adding relevant fact at the right moment, we can boost the model's memorization and reasoning capabilities. I remember these two words, memorization and reasoning, because they are more important when we talk about developing any AI agent. Memory and reasoning, right? And we will be talking about context engineering and memory concept down the line. But these facts, if you inject at right time, they would increase the model's capabilities, and obviously as a result it would improve the both natural language understanding as well as natural language generation, right? And that's where your GPTs would come, where your generative AI would come, right? So you understand and generate. So if I have to talk in simple terms, we are not asking model to think, we are giving additional meaningful data to the model, or something which is meaningful to the models to think with. Means model should consider that and then start thinking, right? And what do you want to give to model so that it start thinking in right direction, right? So that is where you would have RAG come into place, right? So RAG is an AI technique, I would say, where the large language model retrieves the relevant information from the external source. It can be any database, vector store, documents, before generating the responses, right? So essentially, it is then doing two steps. First is retrieval, where it fetches relevant facts from your knowledge bases, your databases, your PDF documents, assignments, whatever that you have, and then it generates, right? Which means LLM uses those facts to produce an accurate and grounded answer, right? So why do you need a RAG? Because as I said earlier, LLMs don't know your private data. Now, a RAG will allow you to inject this domain knowledge into LLM at runtime to ensure that you get more accurate answer, you get up-to-date responses. You don't need to retrain the model, but then there is one important fact that RAG also does. And if anybody can answer, what are the typical challenges with LLMs today? Any idea? I would keep asking the questions, right? So that there is an audience. I know that somebody is listening. Otherwise, it becomes difficult as a one-way talk. You can type in your messages also, answers in terms of messages. So, what is the typical problem that you see when you use, let's say, Chat GPT or any LLM model, right? No idea. Nobody used Chat GPT, or you used? That's a quite silent listener team, I would say.
So are you using ChatGPT?
Yeah.
Yes, sir. While using ChatGPT, so many times it is giving answer like uh, data analytics process. It is not done properly. So it is in process. So we can't able to provide accurate data like that. So I faced many times this problem, sir. I received many answers like this, analytic problems, data analytic problems.
Yeah. So what you would term that is hallucination, right? So your AI model confidently is generating some information, but it is actually or factually incorrect. It is made up, and it is not supported by any real data, right? And that is where you would see. Example, you ask who invented the smartphone. Your chat GPT would reply, the smartphone is invented by, let's say, John Smith in 1985, right? It's a confident answer, but it is completely false, right? And why does hallucination happens? It is because LLM generate text by predicting the most likely next word. It does not verify the facts. So what are the common causes for it? Obviously, it doesn't understand the complete context, or there is no context at all. You have ambiguous prompt, the questions. You have a training data gap, and this is what causes most of the hallucination, that your training data gaps are there, and that's where RAGs come into play, so that your training data is augmented, which means you have a less of hallucination in AI. And that also puts reasoning pressure, which means you force a model to think with the data, because if you don't inject RAG, then you are forcing the model to think without the data, right? And that's where an important thing in terms of any LLM, when you are trying to use it as a business application to your system, is to provide them the contextual data through RAG, right? How does it work? So we start with documents. So documents can be PDF, manuals, contracts, emails, whatever it may be, right? The first step is document chunking, right? What do you do in chunking? You break large documents into smaller, meaningful sections, right? So when you do a section, for example, you have a 10 page or 100-page PDF document, how would you chunk it? Will you chunk pages by pages, like first chunk of 2 page, second chunk of 2 page, likewise you would have 50 chunks? Or will you chunk by a smart method, that you understand that first paragraph in this page 1 correlates to fifth paragraph in page 50, and now such correlated paragraphs should be put into one chunk, so that you get a better context, right? So there are chunking methodologies in place, right? I would call it smart chunking. So once you chunk, the next step is tokenize, which means they are tokenized, and then they are converted into embeddings. Now, embeddings are nothing but the numerical representation of the text. All these embeddings are stored into vector database. So what are those vector database? Those examples are, let's say, if you are Postgres fan, you have PG vector as vector database, Pinecone, Viviate, or you would say OpenSearch. These are all vector databases, right? So you would, the first thing that comes into play whenever you are doing any AI related application development is the choice of database. Obviously, for documents, if you are handling document within your systems, you might use document oriented databases like MongoDB or DynamoDB or whatever it may be, where you would store your documents, and then which means the metadata of the documents and linkage of the documents goes into MongoDB. The actual PDF can go to object storages like S3 buckets or storages within Azure, right? And then the next technology component comes is the vector database. Now, when the user asks a question, the system takes the user prompts. What are the prompts today you are writing into ChatGPT? It's the same prompt and generates the embedding for that prompt as well, right? Whatever the query that you have typed, right? So this query embedding is then passed to retriever, right? So retriever will do a search in the vector database and pull back the most relevant chunks of the information, right? Those related retrieved chunks from the prompts are now becoming your context, right? So important thing to understand is how does the context get built when you send a query to a chat gpt, right? So when you put any text into chat gpt, it would actually take that text, generate an embedding of that text for the query. Then this query embedding is passed to a retriever somewhere. So that retriever will again search into the vector database, pulls back the most relevant chunk of the information. And that chunk becomes your context for model to reason out, right? Now the user prompts and retrieved context are combined together and then sent to LLM. So this is where key thing happen. The LLM is no longer answering from your memory alone, right? It is answering with the fresh, factual, domain-specific information from your own documents because you have passed the entire information of document through embeddings to LLM, right? So that's where model then prepares the response, which will be more factual, grounded, aligned to all your internal documents, right? So in short, what RAG does is transforms the LLM from base-based system into a fact-aware assistant, right? By injecting right information at right point in time relevant to the prompt that you have sent, right? So that is the job of RAG. Now, how does AI agents use these, right? What are those AI agents? How does they use it, right? So that's where I would start with LLM-based autonomous agent, right? So AI agents that use LLMs as a reasoning engine. Now, what does that mean? So LLM act as a reasoning engine, which means they think in natural language. They break down problem and planning steps like human, right? Now there are no hard-coded flows. So what does that mean is, if you, let's take an analogy here. You have an agent, consider a dog, anything that can act on its own and make decisions. So dog is your agent, right? Because if you give an instruction, it does that, right? What does AI agent do? It acts on its own, make decisions similar to what human or dog does, right? But it can also use the tools to execute actions and gather new information, enhancing its decision making process, right? And that's where the difference between agent and AI agent is, right? Because it also uses additional set of tools to execute actions and gather new information, enhance its own decision making process, right? And that's where LLM based agent play a role. So they are reasoning engines, means they think in natural language, they break down problems and planning step just like a human, right? We are all engineers and we all believe into first principles, right? What does first principle says? Any problem you need to decompose into a smaller units that can be easily solved, and that's how your software engineering also works, right? Given a requirement document, what you do, you identify user stories from it. For that user story, you identify a particular set of functionality. Now to implement that functionality, you might need certain UI, you might need certain backend, you might need certain database components, right? So from story, you have split it into these three. Now within UI also, now you would say, I need this CSS, I need this JavaScript, and I need this React code, right? On backend side, you would say, I need this API, and within that API, there would be certain set of functions. Now, each of these functions, you would apply your OOPS principles and then decompose them further, right? You might use polymorphism, you might use inheritance, so on and so forth. At the end of the day, what is the smallest granular unit is nothing but your function, right? So you're actually going through a first principle route. Similarly, LLM also does the same thing. They break down the problem and planning steps into a smallest possible solvable unit, right? And that's where their actions are not hard coded. So they dynamically decide what to do next based on the context. Remember here, every time agent has to do anything, it needs to know the context. To need to know the context, it needs to get that information which is additional coming from RAG and not from the public source which LLM knows, right? Because if LLM knows, then obviously it doesn't need to dynamically decide, right? Because pre-trained data, you already have decided what needs to be done, right? So they combine the knowledge, language-based planning, with real actions, right? So what do? They call the APIs, they call the database queries, they search the database, they execute workflows. So what they have done, they have combined language-based planning with the real action, and then they operate non-deterministically, which means they adapt, they would react, and they would self-correct based on the new inputs and outcomes, similar to our decision making, the human decision making, right? So actually whatever agents are doing, they are actually mimicking the way humans behave if we are provided with additional set of data, right? And that's where the AI agents come into play. So the user provides the input, I would say you call it prompt, but instead of generating responses, LLM begins now reasoning and planning in natural language, right? Remember, LLM not only generates, but it also reasons out. And there are models which are now moving ahead further to reasoning, starting from DeepSeek. So that way you would see more of a planning and reasoning is done by LLM than your agents, right? And based on that plans, the agent decides which tools or actions it needs to use. For example, my plan says I need to get weather information, which means it needs to call a weather API, right, to get the data. My plan says that customer contact number has to be called, which means it would go into database, search for the customer, get his phone number, use the dialer, and initiate a call with the customer, right? Which means there are certain set of workflows that it is triggering out for the outside world. Remember, it will be always for the outside world. And the result of those actions will come back as an observation again. And then using that observation, LLM will again think, adjust its plan, and then revise the execution, right? So this loop will continue until the agent will complete the task that is given in hand. So agent is not only answering the question, it is acting, then it is adapting based on the observation and interacting with the real world. So that is where the job of agent is. I mean, take input, behave with observation, and provide the results, right? Now, so when it says that agents do reasoning, what does it mean by reasoning, right? Can you explain what does reasoning mean? So it is how you figure out things, right? You reason, right? Why you call a blue shirt or blue color as a blue only, right? There is a reason for it, because that is color coded. There are certain set of parameters that has been given, right? So that's where you are thinking that this color is blue, which means you are thinking step by step. And then you are also taking the examples of intermediate reasoning step, right? So that is where your reasoning capabilities get activated, right? So this approach is enabling the agents to break down the task, as I said earlier, into smaller parts, and then methodically work through each step, right? So they logically think through a problem or situation based on the given understanding and reason out, right? And there are certain techniques for them to do that. Many of you would have heard about zero shot, few shot, and chain of thought, right? So these are all strategies, I would say prompting strategies, that would affect your LLM's reasoning accuracy. So if you look at it on top left, if you see there is a problem statement, right? Zero shot means, let's say input, a small sunflower has 3 dozen seeds and large sunflowers has 50% more seeds than the small sunflower. So how many sunflower seeds are there altogether? So if you look at it, 3 dozen means 36, 50%, which is 18. So without any reasoning, direct reasoning, it would be 36 plus 18, which is 54, right? So what it did, with a direct reasoning in a zero shot mode, the model is given the problem with no example and no reasoning instruction. So it directly jump out to an answer 54. Whether it is correct? Not, because the model is not encouraged to break down into steps, right? And that's where now you are encouraging the problem with zero shot, right? So let's go step by step. So if model will decompose the problem into smaller problems now. A small sunflower. Now you have 3 dozen means 36. Last sunflower 50% more means 18, which is 54. So total is 36 plus 54, 90 seeds, right? So that's where the correct reasoning emerges, right? Now, where does this 54 came into play? Because last sunflower has 3 more seeds, right? Now that's where some reasoning has been brought in by the model, right? Now this is one example where you gave him a zero shot. Now we are giving few shots, right? Where with example problem and step-by-step solution. So this teaches the model the expected reasoning pattern, right? So when we give this problem again, the model will follow the learn structure and produces the same breakdown of right? So zero shots will never give a structure. Chain of thoughts will guide model to reason, and few short chain of thought teaches how to reason based on examples, right? So that's where these three strategies are more important for you when you are developing any of the AI application. Zero shot prompting, when LLM is given only the question to ask, right? There are no examples, there is no reasoning guidance. The model will only rely on its own pre-trained knowledge to produce the answer, right? For example, another example can be calculate total number of sunflower seeds, right? Or use case. So when do you use such zero shot prompting? Is when you have a simple task, you know factual question and answer, or the examples for the task are not available, you would be using zero shot prompting, right? But then most effective would be chain of thought prompting, right? So COT prompting instructs the LLM to show intermediate reasoning step by adding cues, right? So sometimes you would have seen your chat GPT keeps saying thinking, right? You would see a background text that is coming, thinking, reasoning, and so on, which means what? They are using COT prompting where they are thinking step by step. So what does it mean during COT prompting is it is activating the model's latent reasoning ability and significantly improving the performance on the task requiring logic, the mathematics, or multi-step thinking, right? For example, you are saying, let's think step by step. A small sunflower has 36 seeds, then there are 50% more means what, and so on. So any math problem that you are going to give it to LLM models, you better use chain of thought prompting, right? So use cases would be mathematical problem, wherever logical reasoning is required, planning or tasks that are requiring structured thought, you would be using COT prompting. And third is few shot. Now, few-shot prompting provides the model with one or more example of the task, right? Including the correct reasoning process or the answer. Now, before it asking to solve a new or similar problem. So, what does this mean? You are actually helping the model to infer the pattern and the format that is required. For example, you have an example question, you have example reasoning, and then you are providing example answer. Now, when you give new question, model will follow the same reasoning pattern and give you the correct set of answer. So when should you be using few shot prompting? So this is either when you want model to mimic your specific style, your format or reasoning pattern, right? That you want model to behave in a particular way only. Then you would be using few shot prompting. Any questions if you have on prompting technologies, right, or prompting strategies, because these are important whenever you are actually developing your AI applications. How do I manage, when do I tell AI model to use few shot versus COT versus zero shot, right? So that plays an important role when you develop any application, right? Now, coming, so what happens with reason and act? Uh, Whether reasoning alone is enough for the AI agent? Obviously, it is not, right? What you need is agent to think. So, how does AI agent interact with real world? So obviously it would call API, it would call external system by pulling data, which means reasoning is done on deciding what to do, and actions are making it happen in the real world, right? Now, how would you validate, or how would agent would validate whether it is reasoning or not, right? Any cases, how would AI agent know whether it is reasoning? How, as a human, you know you are reasoning? So you would examine the results of your own actions, which means whether there is successful, you have failed at some steps, or you have written something else, right? Or you have written data. Then you would check your own constraints, rules. You would have your own business logic. Now you would be comparing the expected versus actual outcome, means you would go past history and figure out what was the expected one for similar scenarios and what is the expected ones. And obviously, not but the least, you would use feedback loops, right, to correct your mistakes. So this is the validation steps that makes agent reliable and safe. So the reliability will come into the agent when you incorporate the feedback loops, right? What is the feedback loop mechanism in ChatGPT? You have thumbs up, thumbs down button, and then in Claude, if you look at it, it takes you the message as well. What happens behind if you put a thumbs down? LLM knows that now this answer is not liked by you, which means there is some reason that this LLM could not generate, or GPT could not generate the right set of answers. So it would again reason out historically to figure out what has happened wrong there, right? So that is where agent keeps on validating, right? Now agent also learn from the environment, right? From, because you from the outside world, it would get the observation, you would know the internal reasoning state, and that is what is called as reactive reasoning. So whenever you are observing the outside world as an AI model and then performing internal reasoning on that, it is a reactive reasoning. So similar to the humans who adjust the decisions after seeing what happened, right? So your AI agent that you have developed or you are developing should be able to perform reactive reasoning, right? And that's why I would say reasoning is not enough, because reasoning stays inside the model. To be useful as an agent, you should able to act, you should able to observe, you should able to adapt, and you should be able to iterate, right? So when you are developing any agent, AI agent or agentic AI workflows, you need to tick mark on these four factors: whether it is able to act, which means whether it is able to perform real task, whether it is able to observe, which means what has happened, okay, then adapt, whether it has updated its next move based on what has happened, and whether it is iterating. And that creates a closed loop, right? So you would see reason, act, observe, reason again, and that's where you call it react, right? So you have reasoning, acting, observing, reasoning. So each of these models today do the same thing in the loops. That is the closed loop principle for AI agents, right? So that covers the basis for RAG, LLMs, and how do they reasoning. But why do you need AI agents, right? And there were agents as well earlier. Those who know RPA, robotic process automation, also used to do execution of workflows, right? Where people used to create their workflows and automation, and RPA will just do its job. A simple example can be that whenever you are buying any insurance policy, you or any bank, you are opening a bank account, you have a pre-filled form where you in the boxes you write your own details. It is given to the RPA agent, which reads the characters from those boxes and then performs the next set of tasks like creation of a user and everything, right? Now, what has happened there? You have 100% of people create and maintain this automation, which means you have to write your own logic when you are developing RPA programs or RPA agents, and then they just execute, right? They don't actually plan and react, right? That's where agentic comes into play. So it starts with 80% human, 20% agent, where you give prompt, you give observations, and so on and so forth through prompting, be it zero COT or few. And that's where gradually you see that human involvement gets reduced and agent involvement is more. And then finally, it is 100% agent. So what does that mean? When you are moving from robotic process automation to agentic, what are those differences, right? Because both are doing similar set of tasks in terms of repetitive tasks or reasoning tasks, right? So RPA will do a repetitive task or automate a repetitive task, whereas AI agent will automate the planning and then act on top of that plan to achieve the desired goal. In the end, both achieve the desired goals. However, the jobs to be done and the way the job to be done is very different, because RPA is more of a rule-based workflows. They are focused on the static repetitive, whereas agent is not focused, right? It's a dynamic. So depending on the planning and action, it can execute its own task, right? Now there are scripts that you end up writing, as well as API automation tools that you use like Blue Prism or UiPath or any other robotic process automation to help uh, the automation of digital tasks. Where in case of AI agents, you can use multimodal AI with LLMs, APIs, and provide contextual understanding so that it can dynamically execute multiple sets of tasks, right? So it can execute non-linear workflows, whereas in case of RPA, it is more of a simple workflows which are repetitive of the nature, and it doesn't handle complex tasks autonomously in case of RPO, whereas in case of AI agent, because of its reasoning capabilities, it does handle complex tasks automatically. So the difference is in terms of volume of processing, right? RPA is good when you know that structured tasks are there, and then if they are of repetitive nature, you would use RPA. But whenever there is an unstructured and complex task, you would end up using AI agents, right? So that's the difference between AI agents and RPA, right? Now, in the context of AI, you started with generative AI, right? So, what does generative AI means? So, obviously, it's a class of technology and techniques, I would say, that use the large data set and advanced set of models like GPT-3, GPT-4, or any other large language model to generate the new content. Remember, it is only generating a new content. It is not actually acting on a particular set of tasks, right? So, example is obviously you are generating a text, code, image through Chat GPT or Gemini, Nano Banana, whatever it may be, right? So, it is learning a pattern from the corpus that you have and then uses that knowledge to create an output similar to what you think it is like a human produced output. So, in short, if you look at it, Gen AI generates the content by learning from large amount of data, nothing else, right? Whereas in case of AI agent, AI agents are the applications that are designed to achieve specific goals by following you have your predefined rules, you have workflows, and you have logics. So what are they doing? They are automating the task based on the deterministic decision trees or your instructions, right? So traditional AI agent will follow the rules, execute the workflows. They would have limited autonomy, so obviously they react within their own boundaries, right? So traditional AI agent will act. It will act within its given boundary and given logic that you have supplied to them. What does AI, agentic AI does? Agentic AI will bring more level of autonomy. So systems that just don't think, but they also act, plan, and adapt, right? So agentic AI systems set or interpret their own goals. They make decisions dynamically. They use tools and APIs. They learn from outcomes and adapt to the new situation, which means they are doing the end-to-end task execution. They are not only just doing content generation, which means agentic AI is enabling systems to reason, adapt. So moving from passive assistant to a problem solver, right? So that is what generative AI is doing. So whatever I talked about, it's a summary in terms of getting those definition right, right? Between Gen AI, AI agent, and agentic AI. Any question before I move on to next set? Is it making sense? It is not making sense, or too much of information overload? Wow. So does your student also remain so silent in the class? Sorry, somebody is speaking, but there is a humming sound. I'm not sure whether you have any questions, whether it is going fine. You can type in. Not necessarily you need to speak. So there are 50 participants. Ideally, I would expect one or two, if not more. Going good. Okay. So now let me hit the key aspects of agentic AI, right? So I talked about goal oriented behavior, right? Which means you need to set the goals, uh, where you can plan, adopt, reason, act. Next thing is you need to have multi-agent conversation. An agent has to coordinate with other agent, like human coordinate with other humans, right? And then they delegate the task. Now, when one human delegates a task to other human, what does it do? It communicates. It either requests or orders, right? Depending on the authority or power that you have, right? Being a teacher, you would always try advising or ordering your students. But with your fellow colleagues, you would try always requesting, right? So an agent also has to decide its level of hierarchy, its level of authority, and based on that, it has to coordinate, which means it can either direct another agent to execute a task, or it can request another agent to perform a particular set of tasks. And that's where some of the async and sync mechanism come into play. Those who have worked on WebSockets and networking, there are two mechanisms, synchronous and synchronous calls, right? So ideally, if I am ordering anybody to perform a task and give a result back to me in a specific set of time, I would rather wait for them to complete and then get the result back, which means kind of a synchronous, and because I'm not doing anything else but waiting for them to complete. Whereas in asynchronous, you are doing your own job, and then once they have got the result back, you would combine them, right? So your agents also has to do such kind of manipulations, and that's where there are protocols to handle that, right? Obviously, learning capability, we spoke. Memory is the most important thing. And then workflow optimization. So when the tasks are getting or orchestrated by AI agents, they need to efficiently identify what are the tasks using the natural language, because all the inputs are in natural language, then initiate a particular task and reason out on the output of the task, right? So that are the four key aspects of agentic AI. You need to have goal oriented behavior within your agents. They should be able to talk to each other, which means multi agent conversation. They need to have learning ability, and then there is a workflow for agent to agent communication. So that workflow needs to be orchestrated and optimized, right? Now, how do you differentiate between Gen AI agents, and agentic AI? Now, I earlier said, right, purpose is different. I mean, in terms of Gen AI, purpose is to create content. AI agent, it is automate task, and agentic is going fully autonomous, right? Which means you would plan, reason, act, right? Decision making, does Gen AI does any decision making? No, it only generates the content. AI agents will do decision making, but within the predefined boundaries. Whereas agentic AI is highly autonomous, which means independently it can take a decisions, right? So adaptability, your GenAI responses are dependent on the data that has been shared, right? Whereas in case of AI agents, it is limited based on the predefined rules. Whereas in case of agentic AI, agents will adapt to new situations. They would learn, self-correct, and improve, right? So that's the major factor of adaptability difference between GenAI versus agentic AI. Now, can GenAI handle uncertainty? Obviously not, right? Because it requires human input and for the unexpected cases, right? That's how you should be generating the content, right? So there is no capability to handle uncertainty in case of GenAI, whereas when it comes to agentic AI, they can fully reason and solve the problem. Which means, in terms of automation type, GenAI is only suitable for, let's say, content generation NLP use cases, whereas agentic AI down the line through agents is suitable for your end-to-end process, process automation, right? And process automation with autonomy, because in RPA there is no autonomy, whereas in case of agentic AI there is an autonomy that is involved, right? Which means your human dependency is very low, whereas in case of Gen AI, human dependency is high because output is dependent on the prompts that you are providing to it, right? So ChatGPT, your text that you generate is the clear example. But in case of agentic AI, if you are a Microsoft fan, you would have seen Copilot. Or for that matter, if you are as a developer, if you are using Visual Studio GitHub Copilot, you have agents which based on the prompt would write additional set of code and then reason out whether those codes are correct or not, right? So that is where the difference comes from Gen AI to AI agents to agentic AI. Okay. Now, what are the core characteristics? I spoke about all these characteristics earlier as well, right? In terms of adaptability, decision making, goal oriented behavior, so on and so forth, right? So, what does that mean from the developer perspective now, right? Now, your AI agents can be divided into tasks, and these tasks will have their own independent parts. Now you would tune those parts that are dependent on the task so that you make them specialized tasks. So for example, now in this case, you have agent. Your LLM is independent of task. LLM, whatever the task that you need to perform, LLM has no play in it, right? Your agent architecture is independent of task, but it uses prompts which are dependent on task. Why I'm saying prompts are dependent on task? Because your prompt defines what task you need to provide. For example, if you have to write a code that solves the bubble sort problem, my prompt would be: you are an amazing developer who knows, let's say, C++ language very well. Your job is to solve the bubble sort problem in a simplest possible way, right? Which means your prompt is dependent on the task, whereas your agent architecture that uses the prompt is independent of the task. Your knowledge is also dependent on task, right? Because unless and until your LLM knows how to solve a bubble sort problem, it won't be able to give the right set of answers, right? So again, whatever the task that you are assigning it to the through the agent, they are dependent on the knowledge and the tools, because tools will provide the capabilities to get the data. For example, an agent with a task to get the weather information will need a weather API tool, right? So that is dependent on the task. So when you develop an AI agent, you need to figure out what are your independent of task activities and what are your dependent on task activities for a particular task for which you are writing an AI agent for. And your dependent on tasks will drive your independent of task. For example, which models to be chosen, whether I need to use Gemini or Anthropic or OpenAI. These are all providers, right? But underneath the providers, each of them has various set of models, right? So how do you identify which models to be used? For example, let's say I am using Olama locally, right? So here that you would see that I have Olama installed, but I have not shown you the models, right? Olama, and then I would say show, or I would just say list first. Oops. So here, if you see locally on my Mac, I have Minstrel Grammar Checker as one of the model. Then Minimal LM, which is another model. Then embedding model from Nomic, and then DeepSeek, right? So and then I have Llama 3.1, which is of 8 billion parameters, right? So I have 4 or 5 models deployed. Now, if my agent has to correct the grammar from the given document, right? Now, by So for example, my agent is writing a document. It's a content generation task. But to write a document, it needs to get certain set of information. Let's say my company's audit report. Now, audit report generation is a generative AI task. But data that is required for audit report generation has to be fetched from various systems, financial systems, ERP systems, and so on. Which means I would have tools that would give me the data from each of these systems. I would have knowledge about this data. For example, what do you mean by EBITDA? What do you mean by tax before earnings, right? So on and so forth, right? So that is my knowledge. LLM has its own knowledge. Now, to build a report, I might generate the content, but I need to do a spell check in that content. I would have a grammar checker model as well, right? So Mistral grammar checker model, right? I might have to generate the embedding from that particular document. So I would use this model, and I would need to reason. So I would use DeepSeek, right? So depending on your tools or dependent on tasks, your LLM will change, but it provides the specific set of capability like grammar checker or reasoning, and that's why it is independent of task. So AI agent will define task and use independent of task LLMs, right? So that's how, as a developer, you would start breaking your agent into these 5 or 4 first categories and then figure out what needs to be done. So what do you mean by what needs to be done here? So you need to now, from the architecture perspective, figure out what are my flow types, right? Your workflow would be of planning and memory, and they include the knowledge and actions. So I would have a sequential workflow. So sequential workflow means in that case, agent will follow the simple loop, right? You would have plan, action, observe, replan, and act, right? So this is useful for tasks that unfold step by step or depend on the feedback from each action, right? Whereas you have plan and action type, which means agent first build the multi-step plan during planning phase, and then in the execution phase it would carry out each action, checks the environment outside world as I used to refer earlier, and applies self correction that are needed, right? So this approach is powerful for complex tasks, right, that requires foresight, that requires multi-step reasoning. And the third is tree type. So the agent explores multiple possible actions from the given step and then evaluate its states and chooses the best branch, right? So this is like a decision tree approach that we have studied in data structures, right? Or a Monte Carlo planning scenario, which is ideal when the agent must consider alternatives before doing a final decision making, right? So in all these cases, you see, be it sequential, plan and action, or tree type, agent is just not thinking. It is continuously planning, acting, observing, and adapting to the goal autonomously so that it achieves the desired results, right? So that is what you need to find out when you are developing an AI agent, whether I'm going for a sequential or by plan and action and by tree type. So how do you know that? You know it based on the problem statement that you have it in hand, right? As I earlier said, in agentic AI also, right? How do you decide which type of prompt to be used, which type of methods to be used? So based on those rule executions and interpretations, you would be able to figure out whether you need what kind of workflow, sequential, plan and action, or tree type, right? And once you do that, it would be able to solve the problem. And to solve the problem, it needs additional set of capabilities or technologies. So what are those capabilities? One is obviously theory of mind, which understands the state of the counterpart. The second is, again repeating, memory, where it would make decision based on past experience and knowledge. Self correction, correct errors and plan, and self evaluation, right? How do you self evaluate yourself, right? So for that, what you have are the development frameworks now. So we looked at what is an AI agent, how do you differentiate from Gen AI to AI agent to agentic AI? What are various workflow types within the agentic AI workflows? How do you do prompts? How do you decide what type of prompt is good for you, whether single shot, few shot, or COT? And then now looking at the agent scope that you have, what I need to achieve, you need to choose the development frameworks, right? So for example, if you have agents that easily test task dependent parts, right? You will use chat gpts or copilots or bedrocks of the world, right? So agent architecture in this case would not change because they are specifically easily test task dependent, right? Whereas there are agents that allow selection of llms, and then agent architecture and prompt writing. The use case that I was talking about, creating audit report where you do grammar checking with a llm, which is different one than generation, which is olama or through gpt and so on and so forth. And that's where you require chaining there, and that's where you have langchain agents or llama index agent, right? That agents can be developed from the agent architecture itself, right? And that's where you have lang graphs of the world, which provides you capabilities for the thread management and state management within the agents, right? And we will when we build that agent down the line, in next 15-20 minutes we'll start building the agent. We will see that how do you manage the thread, how do you manage the memory, and how do you manage the state, right? And then you have multi-agent capabilities. This is the agent that we are going to do, multi-agent, where you would use langgraph again, but you are going to communicate between agents, and that's where these protocols come into play. So if you look at AI agent, you have llm, you have agent architecture, prompt knowledge, and tools. So considering that, I would just skip in terms of how do you develop the agent, right? So obviously I am reiterating what I said earlier. You would define the business process, break down it, you identify tools, then you would identify what business knowledge LLM lacks, get that knowledge ingested at the right point in time through RAG, then identify which LLM is good for which of these tools for action, and then develop the agent architecture, and at the same time do a right set of prompt engineering, because prompt engineering has an important role to play in terms of your capabilities of the agent, removing hallucination from the responses, as well as cost optimization perspective. Okay, so that covers the basis fundamental parts of the agentic AI, and how do you differentiate between Gen AI, and what are the capabilities or things to be considered when you are developing the agentic workflows, right? So in terms of architecture needs, now what do you need? Because you have distributed data, your data is very different. In my scenario, where you are actually trying to generate audit report for a company, your data lies in ERP system, CRM system, then maybe some data from your HR system, and so on, right? Which means you need to orchestrate interaction between distributed data sources and tools, right? And then there will be multi-level processes as well, so you have to orchestrate between multi-level processes, hold the state permanently, potentially for longer period of time. When I say state, what does that mean? A simple example which is not relevant to AI is a shopping cart, right? For example, you go into amazon.com, you add a particular product into your cart, okay, which means you started a buying process. As part of buying process, you identify a particular product, added into the cart. Now, once you log out from the Amazon, does that product from the cart go away? No, your shopping cart state is still active unless and until you discard the shopping cart or you check out. Now, this process can be a long running process, because today you added into the cart doesn't mean that you would buy immediately, right? You would wait for product price to be reduced, or you might get a better product, right? This can happen for a week or months, which means your process to buy within that cycle is a long running process, staying up for months. Okay. What happens in that case, right? Your state has to be managed by a workflow there somewhere behind Amazon.com, which is managing that, right? And that is what the durability is. A product may get deprecated by the seller. So in that case, your what happens to your cart? Your cart has to be updated by the external event, right? Because seller has deprecated a product which you cannot buy, which means now you have to listen to that events for the product and figure out whether to keep the product in the cart or remove the product in the cart. Now, removing a product in the cart means you have to notify to buyer that this product is no longer available, which means you are sending a signal again through socket or notification and removing it from the cart, which means you are changing the workflow state for the cart, right? So that is where longer period of time you have to hold the state. Same thing applies in case of AI also. For example, research oriented agent. Researching a particular topic can be a 1 week, 2 week, 3 week process, right? You are trying to analyze too much of documentation, changing the prompt, changing the content, throwing new documents over generation, and so on and so forth. Means your AI system has to hold the state of the changes that has happened over longer period of time till your documents get finalized, right? So that is the most important need or aspect in terms of AI subsystems, is the durability of your workflow or the state management of your workflow. Then as workflow comes, you need retries, and obviously there would be self-healing capability. If workflow fails, then what needs to be done? For example, many of you go to, let's say, IRCTC for booking a train ticket. You select a ticket, then it goes to a payment provider. Payment provider workflow fails. Then what? You cannot buy a ticket, you come back, you have to start from a process. There is no self-healing capability there, where if it fails, it should try retrying to another set of providers. If you have pre-configured them, like let's say wallet, you have added your own wallet, you have added your credit card, you have added your UPI number. So ideally, if one workflow fail, that okay, my credit card did not work, should I try it into wallet? Should I try it into UPI number? Which means you are self-filling yourself to ensure that the end goal is achieved. What is end goal? Getting the ticket booked, right? But what is happening in this case is it is not probabilistic or deterministic, so that it retries, right? It just gives up, right? Here, what you need is ability to self-fill and retry until the valid data is returned, and it should support the human intervention. You need to be able to approve or reject, right? Obviously parallel processing is required in all the systems that we are doing today, which means when you are running a parallel process, you need to understand the performance of your agent while they are running it, so that they don't degrade in terms of performance, which means they won't take more time to consume, right? Lesser, I mean, more time to execute, not consume. More time to execute means obviously you would end up leaving your customers, right? If any process like your website, if a page doesn't gets loaded in 3 seconds, you probably leave the page, right? You go to another website. It's the same thing here as well. You may not use that agent, you would start consuming another agent, which means now your agent needs to have a high level or a massive level of scalability considerations, right? Now, while we do that, there are challenges. There is no system which can be developed without any challenge, right? Now, here is the landscape you typically see for the tools used across systems or subsystems within an enterprise. It starts with infrastructure. Some of my infrastructure will use storage, then you would use networks, and then you would use some of the data providers, and so on and so forth. This is infrastructure play. You would have many things within the infrastructure. Then you would have analytics, you would have reporting engines, be it Log, Tableau, QuickSight, whatever it may be, right? Then you would have machine learning capabilities. Then you would have applications. Applications can be of hundreds of types, right? You have ERPs, CRMs, HR systems of the world, internal systems, and so on and so forth, right? And then you would have various horizontal systems as well, right? For data integration, ETL, data intelligence, and on and off, right? So this is the overall landscape, which is unprecedentedly high number of tools that you end up consuming within the enterprise, which means each of these tools will have their own set of APIs, their own set of authentication mechanisms. Not everybody follows OAuth, not everybody follows SAML, which means some applications might use their own username and password mechanism. Some applications will allow me to use my own SSO using SAML. Some applications will ask you to use Google Auth, some which is still anyway OAuth, but some applications may ask you to only use OpenID, right? Which means you have different set of authentication mechanisms. They have their own set of data formats, and that's why your integration becomes complex and time consuming. Now, the complex integrations means you have a diverse tooling, your context management becomes difficult, and then you have a development overhead, because then you end up handling all these requirements in terms of portability. And that creates a security concern when it comes to data privacy or handling PII data within the model, right? I would never ever push my PII data onto LLM model, because then it starts knowing my behavior, right? So that's how they would also learn, right? So obviously there are data privacy concerns there. We also need to do access control mechanisms within LLM, so that they don't start use your data uh, and start using that data for their benefits and share that information to the outside world, right? So considering the growing number of AI services, and obviously integration complexity, application complexity is increasing, your development time and cost also increase because of this complex set of landscape, right? Because you have to do a lot of tooling, you have to bring the data all together, you have to address the security concerns, so on and so forth, to meet the RAG requirement, I would say, right? Now, how do you bring the data all together? And that's where MCP plays an important role, Model Context Protocol, right? So it's an open source protocol brought to you by Claude that enables seamless integration of your AI apps and agents with tools and data sources. So those who have done REST API in web applications, your REST API connects to the data and give the results in JSON, XML, whatever the format it is, right? Similarly, MCP in AI ecosystem will connect to AI application, tools and data, and provide you the desired responses, right? So that's where MCP is open standard to be used for community adoption. It provides ability to securely connect to your applications with your AI, and you have a controlled access to application resources and contextual data. That's why you would see the architectures where people use MCP to expose the data out to your agents, and those agents then use that data to perform next set of actions. Those who have used Zerodha MCP for their own shared trading or monitoring, they would understand how it works. Or try ordering food through Zomato MCP, right? Zomato MCP will know what are the previous hotels that you have ordered from, but then use Zomato MCP in your chat GPT, so that way it chat GPT knows that that through Zomato MCP, it can order food for you for your given preferences, right? So that's where the AI agents are using MCP clients or servers to connect to the underlying data sources and perform set of actions. So how does it works? So you have two components there, MCP client and MCP server. So your server obviously will expose the resources, will expose the tools, and will provide the prompt templates. It would it would act as a resource provider, provide the authentication, authorization capabilities, all the security capabilities, and provide the tool executor. Whereas client will query for resources, right? It will invoke the tools and interpolates the prompt. For example, client might say, "Hey Zomato, I need cold coffee from Starbucks." So now MCP server understands that you need a cold coffee, you need it from Starbucks. Historically, you have requested for cold brew without ice from Starbucks, and it places the order into the Starbucks, saying, "Okay, here is the customer." Here and logs in into Starbucks, create order for you. Right? That's how this MCP plays through your AI agents. Right? So now, what the tools have done? They have retrieved the knowledge. I have earlier drank the cold brew. It has searched my customer profile. It sends a message to Starbucks and updated a DP record that, okay, I have created an order for you. So what are the resources, right? The resources can be exposed by the server. Starbucks MCP would expose me all the product catalog, right? Zomato exposes me all the restaurant and their menu items. Whereas Zerodha MCP exposes all the stocks and my portfolio of the stocks, right? So you would have your own API responses, database records, or files that get exposed, and then you would have prompts for transcript summary, transaction summary, or document question and answers, whatever it may be, right? Which means for a tool execution now, you have a set of protocol, open source protocol, which is available so that you can seamlessly write your own tools that can integrate via common specification, right? So you are trying to solve a complex integration problem. The integration problem that was solved in case of World Wide Web, which is REST API, similarly here it is MCP, right? Now, MCP is allowing you that you have a host with client, it is making JSON RPC call, remote procedure calls to your servers, which in turns are going to your own databases, external tools and apps and getting the data for you. It can be your Claude desktop doing the MCP. For example, if I have a Claude desktop, I would see these are all my MCP server. I have Atlassian, I have GitHub, my CAS, my Jira, my product graph, whatever it may be, right? So you have your own MCP servers, and then it would help you to get the data from those MCP servers, right? Then what you have is prompts. How do you manage your own prompts? We will talk about that, right? Because prompt management is a key capability within the MCP or within the AI subsystems. So you got a client, makes a call to server. Server has a prompt, picks up right set of tools, use those tools to go to the certain set of APIs or applications, get the results back to your MCP host, right? Which is nothing but your AI agent, right? Now note that MCP, although it has been brought by Claude, it is not a Claude thing, right? MCPs can be consumed by your ChatGPTs or any of the Olamas or OpenAI SDKs for sure, right? So your own IDEs, AI agents or Claude can use MCP. Okay. Now, even though you have MCP, that is for a particular agent. How does agent will communicate with other agent, like human communicate with other humans? That's where comes A to A, agent to agent, right? So both are again protocols, both are related to agents, both have clients and servers, and both use JSON RCP, right? So JSON RPC is provide them capabilities in terms of being on a standard framework or specification, but MCP is about agent to service. When I say service, it is the underlying capability provided by your own subsystem. For example, ERP providing you all the payroll data for a particular employee for that month. That is a service. And then agent is invoking that service to get the data for the particular employee. A to A is about agent to agent. You have a payroll agent and you have a, let's say, employee agent. Employee agent will manage all the leaves for the employee, right? So now payroll agent has to talk to employee agent to get unpaid leaves for that particular employee so that payroll amount can be deducted, right? Now if this agent has to talk to another agent, there is a specification or protocol which is agent to agent specification, right? So as I said earlier, why do you need it? You need multi-agent architectures because not everything would be done by a single agent. Booking of a flight can be through Go, whereas booking of the hotels can be through Agoda because both give cheaper prices in their respective domains. But then organizing an excursion can be through Make My Trip, right? So ideally, you are actually planning a holiday where you need to do some excursion trip, you have to book hotels and you have to book flight, but you are not going to consume a single provider like, let's say, Make My Trip or Agoda or whatever it may be, but you are going to get something best out of from each, which means everybody is providing a specific set of capability. And that's where you are actually talking to certain capabilities outside of your organization, but then perform this actions. And a multi-agent architecture is required in that case, right? Can we use MCP for agent to agent communication? Obviously not, right? Because I have already said agent will use prompt to reach its goal. But agent to agent communication is more than a prompt, right? Because you need to pass the context and memory to another agent as well, so on and so forth, right? That's why you need a agent to agent capability, which means your AI assistant talks to another AI assistant effectively in a common language. How do you define that common language? It is a specification, then, right? RFCs that we talk about, like JSON RPC, it's a specification. You would have a A2A protocol, right? So this protocol was initiated by Google, but now everybody is following that when it comes to talking to agents, right? So you would have agent which can be developed using Vertex AI. They have their own agent development kit. You wrote its MCP to connect to your APIs, right? So this is one agent. For example, the booking agent for booking.com, which only allows to book a hotel, right? So hotel APIs, you have a MCP exposing hotel, and then you have a agent for booking hotels. Then you have agent which is for flights using, let's say, Make My Trip. So you would have a flights MCP, and then they are talking to each other to create one trip, right? So that's where these agents talk to each other, that if flight is reaching, let's say, at 8 a.m. in the morning, which means I need to book a hotel day before, right? Because my hotel check-in time is after 12. So how do you make those decisions? Agents will make those decisions, but they need to talk to each other. Hey, I cannot find this hotel on the same day after 12, but earlier day is available, and now that you are reaching early, I may have to book early, right? So such communication between agents is done through agent to agent protocol. Okay. And that brings to a topic of context engineering. Before I move on to that, any questions so far? Because it has been like almost majority of the topics that we covered. So any questions? I'm surprised that in such a bigger topic, I'm not getting. Sorry.
Yes, audience, if you have any queries, you can ask to chat box as well, or you can unmute and ask. It was going good, and I hope it is understood by all, and it is interesting.
Okay. So I will now move on to context engineering, right? So what do you mean by context? Okay. So can anybody tell me what is context? You would have heard about this term a lot, right? In terms of context engineering. Okay. So context engineering is a discipline altogether, right? Where you are designing, you are also structuring, and then you are optimizing all the information surrounding to an LLM request so that your model can reason better, it can act correctly, and it can produce the reliable outcomes. Main three part. You have to reason better, act correctly, and produce the reliable outcomes. So it is more about engineering the input environment in such a way that even if with a average prompt, not about good prompt, it should be able to deliver the result. So in simple world, if I also say, prompting will give you, or prompting is what you say in the model, right? That is where your prompt is. Context engineering is everything the model knows when you ask, right? So context is more important than prompt itself. That's where you would see that people are focusing more on context than prompt engineering, right? Obviously, prompt engineering helps in such a way, but context is more important. Now, what do you mean by that? So LLM does not persist memory of your data. We know that LLM has habit to forget, right? So all the relevant information, be it your requirements, intent, domain knowledge, constraint, they must be injected into the model at runtime, right? We talked about that during RAG, right? So what does good context engineering does? The model understands the task, okay? The it uses the right knowledge, it respects the rule that you have along with the constraints that you have to develop the system, and then produces the consistent and deterministic output, right? The key here is actually developing the deterministic output, and it should avoid the hallucination, right? So for any enterprise grade or any agentic AI system, context engineering is the foundation. If you don't build the foundation correct, your results will never be accurate, right? So what does a context mean? A context can include your user input, which is nothing but your actual prompt, your query, your tone, your language, all the constraints that you have put based on whatever the text or voice that you have made, and then the requirement of the task, right? That I need to achieve this. Then there are system instructions to it, right? For example, earlier example, I said that you are an amazing developer and you need to write a bubble sort problem. Means you have set the role. So here, any time you give a prompt, you say a role, right? That you are a networking professor and you are a computer networking professor and you need to explain 7 layers of the model, OSI model, which means what? You are specifying your role setting. So that becomes your system instruction. It also provides the guardrails and rules, right? Don't provide your answer beyond 7 layers of OSI model. So actually you guardrailed it to a specific set of problem statement. And you also say that you give responses in simple, easy to understand language. So that is your behavior patterns, right? So what does context included so far? Your user input, mm, your system integration in terms of roles, guardrails, behaviors, and then obviously domain knowledge, which comes by default from LLM as well as from RAG. Important thing that comes through context engineering is memory, right? In ChatGPT, some of you would have noticed that every time you initiate a new chat, the previous context is lost, right? ChatGPT doesn't remember. If you have to keep it remembered, you have to create a project, right? And then within that project, you provide certain set of instructions so that it remembers. Another thing that you would have noticed is in a chat, it can continue the discussion it remembers until that chat is ongoing. But at some point in time, you would see a note from ChatGPT that, okay, the window has expired or you have reached the limit of window. And now it cannot proceed further, start with a new chat, right? Which means it cannot keep everything in memory, right? So a memory plays an important role in terms of understanding the conversation, past interaction, personal reasoning, whatever the internal reasoning traces that they have done, right? And obviously, the last but not the least to the context is environment, right? What are the tools, APIs, and this. So together, all of these forms the context window, right? Context window, your user input, your system instructions, your domain knowledge, your memory, and then your environment. So for an AI agent to deliver the task correctly or effectively, you need a context engineering. Prompt engineering is at the LLM level, whereas context engineering is at the system level. The goal is to provide right information at right format at right time, right? It is like your cook or chef who knows the ingredients, who knows the recipes for the perfection. Now, why is context engineering hard for developing AI application? It is like your human memory, right? Some of you have a picture perfect memory, photographic memory, we say. Some of you might not have photographic memory, right? Which means you are limited by your ability or your brain's ability to store that information in your memory cells. So, likewise, LLM models also has a window, right, to store it. They have a limited context window, right? What does that context window means? I already said that, right? The context window is the combination of your user input, system integration, domain knowledge, memory, and environment. So the limited context window, and you have finite token space, which means how much you can keep everything in that window, right? Now, multi-step workflow require different context per step. Booking a hotel, within hotel also, do you need a luxury hotel, budget hotel or not? That is a different step. So likewise, you have a dynamic task and multi-steps within those tasks, right? So memory management is a challenge because agents don't have memory, unlike humans. Humans have a memory, right? And then there is a tool overload because you would have multiple tools that are coming into play, which means there is tool overload. So too much of context or too less of a context can cause issues, right? And that's where context engineering is hard for AI agent, right? AI agent will not be able to match the context uh, unlike humans, right? So a larger window, if it would have been available, you would have better reasoning capability because you would be able to store more facts at once. You would have longer conversations without losing a track, which today you would have seen ChatGPT loses a track for a moment. You can't handle full documents, right? Let's say you gave him 100-page documents, it cannot process it because that is what it cannot keep into the memory, right? Which means you cannot give multiple examples with few shot prompting, right? More the memory, it is better, but today it is not, right? And that's where the challenge of context comes into play, right? So now context, as I said, you will provide system integration instructions. I am a super duper engineer, and you need to develop this code. That's my system instruction. Super duper engineer develop this code is my user prompt. You would have various conversations, and then you would have long-term memory and retrieved information to be kept into that memory. And then obviously you have tools responses. So all these constitutes your context. Now, for a context to be maintained, you need to have memory, right? Now, memory is of four types. So, without memory, agent would, if they are repeating a task, they would keep on forgetting it. How do I have to repeat, and so on and so forth, right? Which means you need a short-term memory, temporary information that is being held into agents context, so that way they can, and they know that how to execute a current task and next task. Long term memory is like persisting whatever you have done so that you can refer to it later on. Episodic is where you log the past event and action and learn from them. And semantic memory is keeping the fact and structured knowledge. Obviously, your embeddings can be part of it, right? Predominantly, keeping a short-term memory and episodic and long-term memory are the challenges within AI subsystems, right? And that's why there is a race that keeps on going to increase the context window, right? Number of tokens that are available. If you see, we started from ChatGPT 3.1 with 128K tokens to now Gemini Nano Banana model, which is 1 million token. What does that mean? Is ChatGPT 3.1 could hold information worth of, let's say, 100 pages of PDF document into its memory when you start a conversation, because the token window was 128K. Whereas now, Gemini can hold information about, let's say, 100 documents whenever you are interacting with it. What does that mean? Is it can learn, it can bring more data into memory and solve your problem in a better way, because it can reason more, because it has lot in memory to handle your task, right? Which was not possible earlier. And that's where your memory management plays an important role in terms of AI subsystems, right? Now, how do you manage the memory? So to manage a memory, what you would do is, whenever you are getting the information in short-term memory, you would extract the facts. For example, I don't like having pizza in afternoon lunch. So what is the fact? Lunch and pizza dislike is a fact, right? Similarly, you would extract the facts, keep them into short-term memory, and then you would have long-term memory where you would keep my preferences, that next time when I come, Zomato would know that this guy doesn't like pizza in the afternoon. Now he has logged into the app at 12 p.m., which means I should not be showing him any of the pizza recommendations as part of lunch option, right? So that's where now they are using long-term memory, like my user preferences, to provide the need, right? And there are certain systems that provide this capability. I am not sure how many of you have heard, but there are certain things like mem0, for example, or getzip. So agents obviously keep on forgetting because they don't have memory, as mem0 written. So for example, if it is a customer support as a agent, then as a customer, if you write, I have new phone number, ideally it has to be got into agent's memory, right? Which means now what, your contact number is this, you are a premium plan customer because you are logged in, you know now this is a premium plan, so it has gone into the memory, right? And then you are seeing that at the third time with your month it is going, which means what, it is now keeping more information into the memory, so that it provides clear set of responses and doesn't ask you same information again and again. For example, today if you log into any of our or contact us pages of, let's say, ICICI Bank or HDFC Bank, they would keep asking you the same information again and again, right? Give me your phone number, sir. Give me your date of birth, sir. Why do you need it? Except validation purpose to be given, right? If you have told them do not call, they should not call, right? So which means what? If they have a AI agent, which today they don't have, but then the memory system is not correct, which means they are not keeping what customer has said earlier as part of his responses and behave according to his responses, right? So that is not happening. And that's where AI memory plays an important role in terms of getting your agents to work correctly, right? So you have short-term and long-term memory, and for that specific interaction, you would have a episodic memory. Combining all these things would be your context management, right? Now, next part is durable execution. If you look at any application, right? Let's say, go to Amazon.com. You are actually listing a product, which means you would have product catalog here. Then you would have product inventory, which would be storing the inventory data into the system. You would have shipping because they ship your product to your home, which means there would be a shipping service. Then they would have cron job to get the details about the shipping, right? You get the statuses for the shipping. Then you would have for order, you need to check whether there is a fraud in that order, somebody who is a buyer who keeps on refunding the orders, or maybe payment failures happen, so you have a fraud. Then for shipment, you prepare a shipment, which means you have to identify whether inventory exists first. You have to charge the customer, which means it goes to payment service, payment is done, and then you ship the order by calling to shipping service. Now, each of these have its own process steps. Some of them are sequential, some of them are parallel. For example, checking a fraud, whether it is a fraud customer, and checking a inventory can run parallel, right? They are independent activity, which means both should run and provide the status. However, charging a customer is a sequential, because unless and until you get the payment, you can't be able to ship that order. Once a payment is there, you have ability to ship. Okay. Now consider a scenario that either in the fraud service, which is provided by the bank, there is a network failure. Bank network is down, which means you are not able to check a fraud. But does that mean that your another parallel query that is running on, which is checking the inventory, should also fail? Ideally, it should not. Now, even if fraud is not there, but you are able to charge customer, you should be able to move to the next step, right? There will be certain business rules like that, right? Which means what? You are managing the state, you are managing the overruns or queue failures and going to the next state. And then there can be payment retries as well. I mean, many times UPI gateway fails and you keep on doing retries. So by that time, what happens to your order, right? Can I still initiate an order and you have ability to retry payment? Amazon today does that, right? You, even if your payment has failed, it will tell you that, okay, we have reserved the order for you, we have reserved the item for you, you can try reinitiating the payment within 2 hours or 4 hours, and then the same orders get processed. Which means what? They are actually storing the state of the payment as well as ordered somewhere in memory or somewhere in state, so that way you don't have to repeat the previous steps. For example, if your payment has failed, I shouldn't be checking about shipment checks, fraud checks, and all inventory checks earlier, right? So that is where we need a durable execution management, right? Now, durable execution simplifies the applications or AI agents so that you don't have to create queues. You would have heard about queues, right? In terms of Rabbit or Azure Service Bus, MSMQ, whatever it may be. Don't have to manage the timers. You don't have to consume or publish the event that, hey, he has purchased it, or shipment status or inventory status is successful, now you can go to payment. So you are actually raising an event, right? So all such event management also has to be handled with retries and rollback, right? That's where durable execution plays an important role in terms of defining a workflow, maintaining the state and coordination for that workflow. And then there are various mechanisms to do that. So durable execution is the abstraction layer. So it is a fault oblivious development process, right? Where actually it preserves the entire application state along with its variables so that you can reinitiate from any failure point with the same set of context, same set of variable values. For example, in previous case, if your payment fail, your product ID was this, you would have additional set of variables like my delivery address is different, billing address is different, then my phone number has changed, whatnot, right? So it would keep all these variable values in memory during the execution of that workflow, even though it is a longer duration time, right? And then use them to reset it at the same state and restart it from the same state as well, right? So that your all services are reliable and correct, right? So when it comes to microservices pattern, where everybody exposes certain set of services so that you can use them to develop applications, this becomes more important in terms of orchestration and reliability. Your shipping can be by Blue Dart, your payment is by Paytm, your order is for Apple iPad, but you are ordering through Amazon, right? Which means what? You would need and such orchestration environment to ensure that the execution state of your workflows are correct, and that's where the durable execution plays a role. Now, what we have seen so far, we have seen RAG, we have seen LLM consuming RAG. We talked about context engineering in terms of managing the memory. We talked about AI agents. There are frameworks or SDKs to develop AI agents like LangChain or maybe OpenAI SDK and so on. And then we talked about durable execution, right? Now let's come developing an agentic workflow towards this demo part. Before we go to development, any questions so far? Anybody wants break so that you can put your chain of thought and ask questions? Wow, I mean, even for a break.
Yes, participants, if you have any doubts, any query, hello. Yes, participants, if you have any queries, you can ask in chat as well, or even you can unmute and you can ask directly to them.
Okay. So in the interest that obviously I'm not getting whether people know about everything about this topic, so might be boring, or they're not getting. But then let me cut short the demo in such a way that we save your time and my time. Okay. So in terms of demo solution, what we are going to do, you have a front end, you have a React UI, which is like a chatbot where it would allow you to select multiple set of agents, right? Which means I need to have APIs where I have a API client which connect to my API server, which is a backend API. And then it also uses WebSockets to send notifications that I have sent a chat, I have received a chat notification, and so on and so forth. Now, whenever I initiate a chat through an AI agent, I initiate a temporal workflow, which is a durable execution. And then that agent within temporal we'll make a tool call, right? Agentic workflows. One to get the weather, another is to do a search on web for a specific item and return me back, and then third is on the LLM side of it to get the results back. And then I want to monitor all these prompts and traces through another component, which is Langfuse, and store all this information into database. So if you look at it, now this is the overall system that we want to build. Now consider that I have built it already. So here is the demo. So if you look at it, this is my UI. I need to mute. I can't mute Mr. Rahul Pawar, but okay. Yeah. So this is the UI I built on React, right? So you have a dashboard where you will be. Okay. You would have new conversation. When a new conversation starts, you have multiple agents, calculator agent, research assistant agent, and then I would have, let's say, travel booking agent, right? Now here travel booking agent says, I am a travel booking agent. How can I help you to plan a perfect trip where you would like to go? Which means now what is happening is I'm interacting with underlying systems. So let's say I want to go to Bali for vacation of 3 days starting 25 December 2025. My Okay, I give this. Now this is similar to your chat GPT, right? Now chat GPT, you pass it, what happens? Can anybody tell? We discussed so far. So for my query here, it will do embeddings. It will go to retriever. Similarly, it would have retrieved knowledge and embeddings within LLMs or through vector store. It will combine those and pass to LLM, which is OLAMA, and then get the result back. And to get the result, you would have your own prompt as well, right? Now here, I would have my own prompt to get the travel booking done, right? I will show you the prompt as well. So if I send this now, what I'm doing is actually I'm running a workflow. Okay, I will cancel this for now. Okay, or ignore. Let's say I will cancel this, terminate this. Okay. So these are all completed. Now, when I send this as a query, what happens? I initiate a agentic workflow, right? Now, my agent for travel booking is initiated and then see what happens. So I send this, which means now I should have an agentic workflow initiated, and then I should be able to get the things running here. One sec. I have forgotten to restart the application. Let me restart. Okay. I need to start the temporal service as well. Let me start that. So temporal is one of the server that I am using. So I would be starting the temporal server, which means a workflow engine through backend. And then I am initiating those workflows. So as you can see, there are no workflows here now, which means I have initiated the temporal uh, workflows. So now my workflow engine is stopped. It is not running yet. through backend. I have initiated it. So temporal is the one that is temporal. So those who have used Uber so far, you would have seen in Uber, you do a ride booking, right? So ride booking is done through a workflow. Every ride becomes a workflow, and that has been a core business of Uber. So booking a ride, and then there was a workflow engine that was required to book such so many rides worldwide and show the updates of ride to the user in their app, including maps, right? And you needed a fast reliable workflow for it. So that's where Uber developed a workflow called Cadence. And some of the engineers for Cadence left Uber, and they started a company called Temporal. So Temporal is the workflow engine that has been used by many of these AI engines backend to run the workflow. So for example, when you generate an image in ChatGPT, OpenAI, right? OpenAI initiates a temporal workflow so that it can generate the image for you using the LLM model, right? So here now, I'm going to book a travel demo for a particular website. So let me, so this has started. So I'm saying I'm going to Bali. Fair user my workflow not found ID conversation. So it would initiate a workflow now, and then it would give me that my responses are sent to Olama model, right? Olama model will tell me that the responses, right? Now, how does that work? Let me show you that at the backend. Let me open up. One sec. Let me log into the system. To the workflow, I'm facing a challenge there due to my company tokens. Let me just handle it. It is not creating. So once you execute a workflow here, it started. So here you would see that the workflow got initiated. Sorry, not here. You would see that there is a Bali, and now it would ask for a workflow tool under Bali. So how does it traces it, right? So here you would see that now I said that I want to go to Bali. So there is another system called Langfuse. Now Langfuse will allow you to trace all your LLM calls, right? So here what I did is I said I'm using a travel booking agent, and now what is my prompt? My prompt was, you are a helpful travel booking agent and you need to book. Now, you to do a booking, your responsibilities are, you have to collect travel preferences, you have to search for flights, you have to present options, you have to help with booking decisions, and you have to provide travel tips, right? So which means what? As a prompt, you have told the system that you need to actually uh, help user to do this. Right now, what did it did there? Now, considering this prompt, I said give me current weather of Bali also, right? So here assistant said, to get the current weather in Bali, I will use a weather tool. Now, what is a weather tool? Weather tool is a tool that has been developed by me that calls the weather API and gives the output by getting the information. So what it did is it now made a tool call, which is a weather tool call, where the location has been set to Bali. So now I have a weather search as a API call where it get a weather from Bali, which means it went to third party system and actually did a weather tool call, right? Now, once it went to third party system and weather tool call, it got the results back, right? And those results are nothing but the weather there is 28 degrees and below of 22 degrees, which means in your prompt now, your agent actually took this system prompt. User prompt is give me current weather of Bali. You have an assistant, which is AI assistant, which is your AI agent, which got into this, parse that, give me a current weather in Bali. So it has to now detect what weather APIs to be used, what tools to be used. It used the tools and got the responses back. Now you can check the tool execution as well, that using tool execution, now it said, okay, now I have a message, current weather in Bali is this, and then values are this. So what I did here, you had a LLM call, which is get me a weather. You executed a AI agent to get the weather information, and to by executing those AI agent, you got the responses back. Now, if you look at it here, what it has done, it has established a session. Let's see here. Now, latency is 6.45 millisecond, which means what? I'm running this locally on local Olama. That's why you have more latency. But look at it. You have prompt, which is using Llama 3.81 billion. This is the model that I was using, right? Llama 3.81 billion. And then it would provide you the details in terms of tokens as well, right? So how many tokens it has consumed. So if you look at it, for this information to process, now LLM use 166 tokens, whereas output is 77 tokens, right? So this way you would be able to manage all your tool calls from the system, look at the prompts, and then tweak the prompts in such a way that how will you handle information that is being sent to LLM along with instruction, and what is the metadata, like temperature. Can anybody tell me what is the temperature in LLM calls? This is the test whether you're listening to this session or not. What is temperature? No idea? Anybody?
No, sir, we can't able to find
Oh,
out that the answer.
you don't know the temperature, or you have not
No,
heard
sir.
about it?
That value we cannot able to find out that what is temperature value.
Okay. So temperature in LLMs is like, let me just show that value again. So temperature is a parameter for the LLMs that adjusts the randomness of the model in generating the output, right? So in generative AI session, down the line in 2 days, you would see about talking about temperature. But temperature is how your model becomes creative or deterministic, right? So lower the temperature means your model is very deterministic, which means it will always strive for accuracy, it will always strive for summarization, and create a good results. For example, capital of France, let's say if you keep temperature to 0, it will always return you Paris. Okay, because it is like not going creative and it is deterministic, right? Now you would see minimal temperatures as well, right? Say from 0 to 0.3 are the low temperatures, medium temperatures are zero point 0.4 to zero point 0.7. Now medium temperatures provides balance, creativity and accuracy, right? So here I am doing a chart, right? And for a chart, what you need is bit of creativity so that you generate a content, which means for any general chart or you are writing something or brainstorming, you would have a medium temperature between zero point 0.4 to zero point 0.7. So that way your randomness of LLM model in generating the output is addressed. If you want more creative output, let's say I want to write a poem or I want to do story writing or doing creative ideas, I would keep higher temperature, which is zero point 0.1 to 1.2, right? Higher the temperature, more is the creativity from the model, which means it will uh, write something which is very creative, like writing a story. So if you say, I am starting a new shop and give me a tagline for the shop, for such kind of prompts, temperature has to be always more than zero point 0.8. Which means what? When you are developing an application, your AI agent application can be story writing agent. So for story writing agent, your prompt will be, hey, you are a good author and your job is to write a story and your responsibilities are this. And your user would say, give me a story in for a kindergarten students. Now here, for that prompt, you would have to set the temperature to zero point 0.8 and above. So that way it will write a story. If you don't do that, it will always strive for deterministic solution, which means it will never give you correct set of results. That's where temperature plays an important role into these agentic AI architectures or even agent architectures. Is it clear now? Any questions? I mean, if you have any questions, please ask. I mean, don't be shy, because these are the things that would help drive better system designs on AIs and LLMs. Okay. So now we talked about temperature. There is another thing that you would see here is tool calls, right? I made a tool call which is for the weather, and then I pass the location as Bali, and it gives me the result. So if we look at it now, what I did, I passed the two messages. My goal was travel booking, where I got the weather and then I did a search. How is Bali there? Right? So, such things that you would do using the token, right? Through the tracing. Langfuse is one of the tools that would help you trace these capabilities. Okay. Now, the next thing that comes into play is around going into details, right? So I talked about interaction. So your system selects a goal. Now that goal is nothing but identifying location, then identifying Bali as one of the thing, right? So that's where uh, it took weather tool and it started looking at Bali as one of the location, and then started a workflow to get the results of Bali. So that way it was able to actually get into the lo- location specific tool execution, right? So that's where the flow has happened from user, which is like, hey, I want to get the Bali thing, current weather in Bali, to the system, which is again booking agent. You pass certain set of parameters and got the results back, right? So that is how you are using the flow between user and system. And then you have workflow in between, which actually helps you to do a durable execution within that system. And then the third thing that comes into play is the LLM part of it, which I spoke about in terms of running the local OLAMA system, right? So that the three things would play an role within the execution of this program, right? Now, how does temporal workflow do the things, right? So the temporal will actually run and tries to configure LLM in such a way that it would get the signal, it would handle the signals in such a way that all these location parameters, or for that matter any responses, are handled correctly and then passed on back to the LLM engine, so that way results are collated at LLM engine at AI agent level, and then you got the responses back, right, from the workflow side of it, right? So it is just a code that gets executed, and failures are handled by the engine into this execution flow, and then the results are written back from the LLM engine. So here, whatever the interaction that was happening between user and the system, right, that was happening through workflow events and through engines, through the temporal engine, right? So that's how the overall system work. Any questions that you have in terms of components, subcomponents, and the workflow states? So for example, here, as I said, that I want to go to Bali, I didn't show you that, but here is the workflow that it ran, right? So if you look at it, my goal definition was travel booking. My conversation was nothing initially. So now I said, hello, I want to go to book. I am your booking agent. I want to plan your thing, right? So that is how on UI you say, hello, I'm your booking. I want to plan to see this. So this is my UI. And then what has happened? I got a message, user message, right? I want to go to Bali. This is what I typed. Okay. Now I saved that message into the database. So that is where my workflow was. Then I notified to WebSocket that, hey guys, I have sent a request that I want to go to Bali, right? Then I made a LLM call. Now LLM call, what I said is, now here is my input, user input, here is my conversation, and now here what did LLM said to me, that is the result, right? So LLM told me that, hey, this is your result, Bali is a beautiful destination. To get started, can you please tell me when are you planning travel, specific date, and so on, and then it gives me token. Now on this demo, you would see that you have this, right? Hey, Bali is a beautiful location. That is what LLM told me, right? Here, if you can see, Bali is a beautiful destination. So I saw this. Now, how did it ran into Langfuse? I will show that into Langfuse as well. Let me get Langfuse. Where is that? Okay. So let's track this trace as well. Okay. Conversation. So now if you look at it, I want to go to Bali. This is what I said. I want to go to Bali. Now Bali is a beautiful destination. This is what LLM gives me. Now whatever LLM gives me, my workflow durable execution has tracked it as part of call LLM and got the responses back from LLM. Now for that you have a tool call and everything. These are available. Now as it said, I am saying what are your planning to travel dates. So I am saying I am going on 25 or let's say 20th December for 3 days, and I need and I have budget of $5,000 USD. Okay. Now third thing is any accommodation. I would stay in budget hotel. So here as a system, I am sending this information. Look at it, what has happened. Now you would see a user message has been sent. I am going on 20 December for this, right? So I got a user message. Durable execution has tracked that user message. Then send that message, saved that message, sent a notification and called the LLM. Now in the LLM, as you can see now, here you have sent again the same user prompt, but then now on top of it, here you have sent it that I am planning to go on 25 3 days. So LLM, if you look at this now, I will just show you. JSON handler. Here, first conversation was I'm travel weekend. I want to go to Bali. Then next conversation, LLM said Bali is beautiful destination. Then I sent I'm going on this. So for which LLM has to reply back, right? So now if you look at workflow, LLM called up and then called the tools, got this, and then I got the save notification, right? So here you would see whatever the response that LLM has given. So what LLM said is based on preferences, I will start searching hotels. So please note that we are planning ahead. I won't be able to give the forecast for weather tool only provide current information. Once I have this web search, I will present you with this, right? So give me current weather and also provide me hotels. So again, you are sending this information back to LLM. So this is the user message. It went on, workflow got triggered. You are calling LLM now with additional set of context and the memory that is there. LLM got called, tool got called, and then I finally got the response back. And everything that you would see now is there in your traces, right? So here you would see a trace that first, Bali, you got the current weather now. Give me current weather and also provide me hotels. That is what I said. Give me current weather and also provide me hotels. So based on tool results, current weather is this, and then it is trying to figure out the hotels. So here you would see my API for the weather for Bali got called as a tool through agent, and then I got the Bali weather today. But it also asks me now that budget friendly you are, I'm not, I will find the hotel during peak season. So budget friendly hotels. So the such way the conversation continues like your chat GPT. So backend chat GPT, the way you are starting a conversation, backend also chat GPT does same thing. In temporal, it would create another user message. It would initiate a workflow. It would call these activities and workflows, track them as a durable execution, make a tool call, send the system notification, and then get the result. So now I made another tool call to hotels API to get the hotels, right? So I got these three hotels, Fortune Capula, Tuban, and based on the highly rated by previous guest, and so on and so forth, right? So these are the tool calls running locally from my system. So that's how your agent workflow runs, agentic AI runs, and in between it uses prompts and tools and MCPs to perform the execution of the uh, actual problem statement to get the desired results. So this is the overall flow in terms of how agentic AI works. Any questions so far from these three subcomponents? Tracing, obviously there are prompts associated with it in terms of prompt, okay, but traces, you would see a prompt here as well, that this is my prompt, and for each of the prompt running against a model, it gives me completion, how many tokens it has consumed. I would be, if I have to do prompt tuning, there are certain capabilities like prompt scoring, LLM as a judge, where it can trace and gives me whether my prompt was correct, my LLM model was correct, or I need to change the model, and so on and so forth. And agentic AI provides me the workflow capability to monitor workflow at the back end. Although this is back end, on the front end side, what you see are only the results. Yeah, Madhuri ma'am, you raised the hand. Mhm. Go ahead. Ma'am, you have any question? Okay. I would think it is no. So that's how your temporal worker initializes LLM interaction that I have shown, and then get the result back. So towards the end, what happens? You have UI, UI is sending data, data is sent to API to queries. I'm sending that data to temporal. Temporal is creating a worker, passing all the messages through workflow to activities. Activities are sending data to LLM. LLM is providing me the identifying me the goals. Based on the goals, it is identifying the tools to be executed, gets the result back. All this is traced in Langfuse, and I get the result back through temporal activities to workflow to through API back to UI, right? So that's the end-to-end flow of any chatbot agent, and it uses search capabilities, hotel API, as well as the weather API to get the results back, right? So from the code perspective, what is it here, right? So I would show you code. Okay. So as you can see here, I have source divided into two part of it, right? I have front end and I have back end. And then I have worker, which is my temporal workflow, right? So now if you look at front end has my UI, which has various components like whatever the card and button that you see on this UI, so left navigation and everything. And then I would have pages. So pages, I have conversation, the dashboard page that you see here, the dashboard page, right? Then I have conversation page, which is the conversation, and then I have the third page, which is conversation detail page, which is going to any conversation, it will give me the details of that conversation. Now conversation detail page goes by conversation ID, right? So that's why you would see that it is looking for conversation ID from the user parameters, and then showing me all the conversation detail. And there is some logic with that conversation is fetching data from backend system, which means I have a API to get the conversation details. So I have a conversation route which I use to get the conversation, right? So I would have services now that conversation uses. So when I start the conversation, I have a conversation ID, I got the conversation, and then I say trigger my workflow, right? So first I store the conversation into database, then started the temporal workflow that, okay, now my agent has started a workflow. Within that workflow, now I have created the conversation and send the response back to 200. Now temporal, within that temporal workflow, it would initiate the workflow and say that conversation workflow has been triggered. Now it will keep on getting the workflow, otherwise it would trigger the LLM activities. Now LLM activities are coded as a shared ones, right? So here you would see that I would have LLM activities which are related to booking. So I would show you that API. So here I am making an API call. So for example, I have a conversation API where you are getting the conversation, you are sending the message from UI to API, as well as doing the tool execution. Right now, in tool execution, I would have various goals. One of the goal is getting the weather, right? So I would have weather API as well. So you have weather API. So my tool is weather, and then I would call the tool service, right? So where I would say now in LLM, I have a weather call. Now get the current weather by using the to weather calculator, right? So it gets the weather API call and makes the weather. So here is my weather API call. I will show you that. So it actually calls up weather API, which is api.weatherapi.com version 1. And when I pass the parameter, it gets me the current location's weather. So it will give me weather, region, country, local time, temperature, and everything. It responds back weather details to the agent. Agent consumes those as part of LLM activity and passes it to the UI part of it. It also does the hotel search, so that is through DuckDuckGo. So here it is doing a web search. So it is actually doing DuckDuckGo call where it does a web search for the hotels and give me the results. You can use the booking API or hotel API. It requires just a key and payment. I didn't want it to do that. That's why I'm using the open source version of DuckDuckGo to get the web search results, right? So it searches at multiple places, domains, and give me the results back. So that's how my web search weather tools are there. I also have calculator tools, which means now I have multiple tools in my system which are acting as an agent. If you look at this, as an agent and providing me the required set of capabilities within my agentic workflow to build this chatbot agent. So you see you have LLM here, you have workflow here, and you have multiple set of agents like weather agent, booking agent, hotel search agent, and a calculator agent to calculate the trip cost. So that covers the agentic part of workflow and agentic AI. If you have any questions, please feel free to ask. Although I'm a bit surprised that I didn't get any questions in this 3-hour session. Okay, then I will stop presenting. We can conclude if there are no questions.
Okay, yes, audience, if you have any queries, any doubts, so you can discuss or you can ask directly to sir as well. So from last around 3 hours. So sir is explaining about agentic AI, and sir has explained from the basics about what is agent, what is Gen AI agents, and agentic AI. Also, the difference between RPA and AI agents, along with different architectures of agents, AI agent development frameworks, along with agentic architectures. And lastly, sir has explained about MCP, context engineering. And lastly, sir has given a very good demo about how you can develop an agentic AI application by incorporating different APIs for a particular application. Okay, so really, this is a wonderful session and a very informative session. And the forum is open for the participants. If you have any queries, you can discuss or you can ask.
Okay. Looks like no more questions.
Okay, Swati, are you there?
Yes, sir.
Okay, so we will go to the last session, that is vote of thanks. So
Yes, sir.
over to you, ma'am. Okay.
Yes, sir. As Dange sir said that the session was very informative. Thank you very much, sir, for this wonderful session.
Yeah, thank you.
I also thank you all the respected faculty members and participants for attending day 3 of this FDP. We look forward to meeting you all tomorrow for day 4 at the same time. Thank you everyone. Thank you so much, sir.
Thank you.
Have a great evening.
Yeah. Thank you, Deepak sir, and we will also hope the same session in physical mode in college. So we expect that maybe it's for exclusively for the faculty of Sanjeevani. So as per your time convenient, we will plan that.
Sure.
Thank you, Deepak sir.
Okay.
Yeah.
Ange sir, tomorrow timing is same or 5 to 7 to 9?
No, no. So all the participants, kindly note that tomorrow time is 7 to 9 p.m. at evening. So all should join on time for a very informative session on data streaming. Okay. So those participants who are not able to mark the attendance through link, they can scan this QR code for marking the attendance. As well, from our side also, we have tracking the attendance, so there is no any concern. So once again, thank you, Deepak sir, for your valuable time and your informative session on Agentic AI. Thank you.
Thank you.
Thank you once again on behalf of Department of Computer Engineering, Sanjeevani College of Engineering, Kopargaon.
Okay. Thanks. Bye bye.
Okay. Thank you, sir. Bye.